All right, in this video, I'm going to be doing some more integrating factor examples. I'm going to be working through the second half of multivariable calculus homework 5.4. And so this first one, I'm going to start with number 9, is 1 over x dy dx minus 2y over x squared equals x cosine x. Okay. So, minus 2y over x squared equals x cosine x. Okay, so it's, okay, this is not y prime plus p of ty equals q of t, right? I have something attached to the dy dx, so I need to get it into the form y prime plus p of ty equals q of t, and so that I can use the integrating factor technique. Okay, so I'm going to multiply both sides of this equation by x, and I'll get y prime minus 2 over 1 power of x multiplied by y is equal to 2 powers of x times cosine x. Now, p of t is going to be negative 2 over x. Okay, and we know that the integrating factor is going to be mu is e to the antiderivative of p with respect to x. Okay, so the antiderivative of this would be negative 2 natural log x, okay, up there, and then e to the natural log x is x, so it's going to be x to the negative 2. Okay. And then, so that's why the integrating factor I didn't actually finish is x to the negative 2. So I'm going to multiply this through everywhere, and I'm going to have x to the negative 2y prime minus 2x to the negative 3. Negative 2x to the negative 3, that looks right? It looks like the derivative of x to the negative 2. Multiplied by y is equal to, all right, when I distribute it in the x to the negative 2, that'll kill that off, and I'll just have cosine x. Which is nice, because otherwise I was going to have to do integration by parts or something like that, right? Now I can just antidifferentiate cosine, and well, that's going to be really easy. All right, so this is the derivative after taking the product, taking the derivative of a product, y times x to the negative 2. All right, I took the derivative of y and left x to the negative 2 the same, and then I took the derivative of x to the negative 2 and left y the same. And that's going to equal cosine x. Meaning that y times x to the negative 2 is equal to the antiderivative of cosine x. With respect to x, it's going to be sine of x plus some constant. And so y will be equal to x squared sine of x. Oops, close, but not quite fully in the shot. X squared sine x plus c times x squared. Next one is going to be y prime plus y equals t. Okay. Oh, and this one has an initial condition. We're going to say y of 0 equals 2. And so hopefully we can find a particular solution here. All right, in this case, p is looking like 1, because this is 1y here. Okay, so that means to me that the integrating factor is going to be e to the antiderivative of 1. Well, that's just going to be e to the t. That means, what am I thinking here? Oh yeah, I'm going to multiply both sides by mu, so I'm going to have e to the t y prime plus e to the t y equals t e to the t. And, this is going to be a product rule derivative. And then I'm going to have to come up with an antiderivative for t e to the t with respect to t. And that one's going to require integration by parts for sure. Okay, so maybe I'll go over here off to the side. I'll say, all right. Okay, we're interested in computing the integral of t e to the t with respect to t. Okay, and we know that, okay, we're going to use integration by parts. I late algebra before exponential. U is going to equal t, and dv will be e to the t dt. So I'll take the derivative and the antiderivative. Okay. I'll remember that the integral of u dv is equal to u times v minus the integral of v du. And so I'll say that this antiderivative of t e to the t with respect to t is going to be equal to uv t e to the t minus the integral of e to the t dt. Okay, so that's just going to be minus e to the t and then plus c. Okay. And so now when I go to anti-differentiate both sides here, I'll be able to do this one easily. That'll be y times e to the t is going to be equal to this antiderivative I found over here. That'll be and then I will solve for y by kind of clearing out that, or dividing that e to the t away. So y is going to equal t minus 1 plus c e to the negative t. Okay, and now I can plug in to find my value of c. Okay, so y equals 2 when t equals 0, so negative 1 plus c times e to the 0. It means to me I think c is going to need to be 3. So my particular solution is y of t equaling t minus 1 plus 3e to the negative t. Y prime plus y equals e to the negative t. And y of 0 equals 1. Okay, well, this is the same setup over here. This is the same p so I know, as the previous problem, so I know I'm going to have the same integrating factor. Okay, because I've got p equals 1, I know that mu is going to be e to the antiderivative of 1, which is going to be e to the t. Okay. And I can say, all right, well, e to the y prime plus e to the t times y is equal to e to the t times e to the negative t is going to be 1. Okay, now I'm going to say, all right, this one's going to go a lot faster. So the derivative with respect to t of y times e to the t, just like the last example. Okay, so I'm going to anti-differentiate both sides, and I'll get y e to the t equals t plus c. And then I'll say, all right, well, y equals t e to the negative t plus c e to the negative t, just when I divide both sides by e to the t. And then I'm going to plug in to find my initial condition, or to find my value of c using the initial condition. So y is equal to 1 when t is equal to 0. So that's 0 plus c e to the 0. That's telling me c needs to equal 1. And my particular solution is going to be y of t equaling t e to the negative t plus 1 e to the negative t. All right, this one looks like I'm going to need to divide everything by x first to get it in that y prime plus p of ty equals q of t. So that'll be y prime plus 2x to the negative 1 y equals, okay, x to the 2. I'm going to divide x, and I'm going to just have 1 power left. Okay, then I'm going to say, I'm going to get my integrating factor. Mu is going to be e to the antiderivative of 2x to the negative 1. You know, and if you've done enough of these, you know where this is headed. Okay, it's going to be 2 times the log of x, e to the log x is x, x to the 2. My integrating factor is going to be x squared. Meaning that I'm going to have x squared y prime plus x squared times 2x to the negative 1. Well, that'll just be 2x to the positive 1. Okay, good. That looks like a derivative after the product rule. If I distribute in x squared onto that x, I'll have x to the 3. Then I'm going to say, hey, this is the derivative with respect to x of y times x squared. I can anti-differentiate both sides. And then I can divide by x squared. And I'll say y equals 1/4 of x to the 2 plus cx to the negative 2. All right. And then I'm going to plug in to find my value of c, use my initial condition. So y is equal to 3 when x is 1. So that's 1/4 of 1 plus c times 1 to the negative 2 power. Okay, so I need, well, that's 12/4, so I think c is going to need to be 11/4. And so c is 11 divided by 4, and my particular solution is y of x equals 1/4 x squared plus 11 over 4x to the negative 2. All right, now it looks like this one's going to play out pretty similar, and so, oh, but no, it doesn't have the same constant attached to it. So I'm going to start by dividing both sides by t, and so I'll have y prime minus t to the negative 1y equals t to the 2 divided by t is going to be 1 power of t. My integrating factor will be e to the antiderivative of negative t to the negative 1 with respect to t. Okay, well, that'll be e to the negative log of t. Okay, so that would be t to the negative first. Okay. So now I'm going to multiply both sides of this equation by t to the negative 1 power, and I'll have t to the negative 1y prime minus t to the negative 2 times y. That's good, because the derivative of t to the negative 1 is negative t to the negative 2. And then that's going to be equal to t multiplied by t to the negative 1. Well, that's just going to be 1. And then this is the derivative of y times t to the negative first power. And then I'll say I'll anti-differentiate both sides. Okay, multiply both sides by t to the first power. And I have to solve for y, and so that will be t squared plus c times t. And then I'm going to use my initial condition right there. So y is equal to 3 when t is equal to 1. So 1 plus 2 is 3, so I'm thinking c needs to equal 2. And so I'll have my particular solution, y of t equals t squared plus 2t. All right, this next one, xy prime minus 2y equals x to the 4 sine x. I'm going to have to start by dividing by x. It seems to be a pretty popular trend here. I'm not sure how this is going to go. Yeah, it's going to have x sine x. It's going to be a bit of an annoyance, but we'll be able to work with it. Okay, I'm going to find my integrating factor. E to the antiderivative of negative 2x to the negative 1. Okay, so that'll be x to the negative 2 power. And I will distribute that across, and I'll get x to the negative 2, negative 2, x to the negative 2y prime, negative 2x to the negative 3, y, and that sounds like the derivative of x to the negative 2, so that's a good sign. Then when I distribute in the x to the negative 2, was 4 powers, that's too bad, x sine x. But we'll be able to find an antiderivative for that using integration by parts, and it's not too bad. Then this is going to be the derivative with respect to x of y multiplied by x to the negative 2. And now I'm going to need to find an antiderivative for x sine x. This is the second time I've used UDV in this video, so I'm going to move a little quicker through it. And I'm going to say, all right. Okay, algebra before trig. du is dx, v is negative cosine x. Okay, so it's going to be uv minus the integral of v du. Okay, and so that'll be negative cosine x plus sine x, plus c. So when I take the antiderivative of both sides here, I'll have y times x to the negative 2 equaling this antiderivative. Okay. And then I can solve for y by multiplying both sides by x squared. So that'd be negative x to the 3 cosine x plus x squared sine x plus c times x squared. Okay, and that's the general solution. They didn't give us an initial condition, so there's nothing else I can do here. Okay. Next one. ty prime minus 2y equals t squared. Did I not do this exact one? Minus 2. I really thought that was on there, but okay, there's a bunch that are like this. Okay, so integrating factor is e to the antiderivative of negative 2 dt. Nope. Negative 2 over t, right? Because I need to divide this through. I almost forgot that. Okay, divided everything by 1 power of t to get rid of that right there. Okay, so now, yeah, I'm taking the antiderivative of negative 2 t to the negative 1. That's going to be t to the negative 2. Okay. Because it's going to be e to the negative 2 log t, and oh, you've seen how this has gone a bunch of times already. Now I'm going to multiply both sides of this equation by my integrating factor. Okay. Oh, that's interesting. And all right, this is the derivative with respect to t of t to the negative 2 multiplied by y. I can anti-differentiate both sides. And then I'll multiply by t squared. Okay, in fact, I can leave that absolute value just to, you know, in case of domain issues. Okay, but yeah, that's going to be my general solution. That's good. I'm going to move on. I've just got 2 more. Y prime plus y times cotangent x. Oh yes, some people were telling me about this one. Okay, well, okay, plus y times cotangent is equal to cosine. Well, okay, I'm going to need mu equals e to the antiderivative of cotangent x dx. You know, you could write it as cosine over sine and use a little substitution, or you could look it up, and I think it's going to be log of sine. That's what I think. Yes, here we go. Number 11. There you see it. Antiderivative of cotangent u du is log of the absolute value of sine of u plus c. Log of sine. Okay, so that's good. E to the log of sine is just going to be sine. Okay, so that's sine x. Okay, that's an interesting integrating factor. So sine x y prime, maybe I'll write it like that, plus y times cotangent times sine to be cosine, right? Because cotangent x times sine x is equal to cosine x over sine x multiplied by sine x over 1, and so I'm going to just have cosine, which looks good because now this looks like a product rule derivative. Oh, yeah. Okay, I'm not sure what y'all were going to do with this. Maybe, I don't know, look it up on the internet, maybe do integration by parts. I got something better for you. And pull out a different color and remind you of something that I know somebody's told you at one point. And that's that sine of 2x is equal to 2 times sine of 1x times cosine of 1x. So if I had sine of x times cosine of x, that's half of sine of 2x. So, and then I'll say that's the derivative with respect to x of sine of x multiplied by y. Then I'll anti-differentiate both sides, and now it's going to get a lot easier. Equals, that'll be 1/4, negative 1/4 cosine 2x. And then I'll have plus c, y is going to equal negative cosine of 2x divided by sine of 1x, and a 4 in the denominator, I almost forgot that, plus c divided by sine x, maybe I'll call that c cosecant x, something to that effect. And, well, that'll be, yeah, that was more interesting than the average integrating factor example, but I've only got one more, so I'm going to just try to finish it in the time before my class comes in. Maybe this one will be easy. No, doesn't look like it. All right, y prime minus tangent t multiplied by y is equal to negative secant x, or negative secant t. I'm editorializing on this problem a little bit. And it came with the initial condition. Wow. Hopefully I'll be able to do this one quick. All right. An antiderivative for negative tangent t. I think that the antiderivative of tangent is negative log of cosine, but again, best to be sure, and with these like really obscure antiderivatives, you want to just go ahead. Yeah, negative log of cosine's number 10 right there. Okay, so I'm going to use that. Okay, so this will be positive log of cosine is what I'm saying. So e to the antiderivative of negative tangent t, that's my integrating factor, so that's e to the positive log of cosine. Okay, well that's just going to be cosine t. All right, so y prime times cosine t. Tangent t times cosine is going to be sine, so minus sine t times y is going to be equal to, oh, cosine times secant, that's going to be 1. So that'll be negative 1 there. Okay. Ah, this is working out nicely. So the derivative with respect to t of y times cosine t is going to be equal to negative 1. So y times cosine t equals negative t plus c. And I'll divide both sides by cosine t, and I'll say that y equals that. I can plug in to find the value of c using the initial condition. Y is going to equal 1 when t equals 0. So that's negative 0 plus c divided by cosine of 0, which is 1. So it feels like c needs to equal 1. So my particular solution is going to be t equals negative t plus 1 divided by cosine t. Okay. And that's going to be all. 17 integrating factor examples. If you've done all 17, you know what you're doing at this point. Thanks for watching.